This question has a pretty big setup to it, so rather than just jumping in and reading this right away, I just want to point out that this is a probability question, and I usually, when I look at a question that has a large setup and then part A, B, C, D, and so on, I jump right to the questions themselves. Like here in part A, it tells me what it is I'm going to be doing. It says, what is the probability? So I know it's a probability question, and it's a probability of some sort of an outcome occurring. In fact, all of the other parts of this question pretty much say the exact same thing. What is the probability that this outcome occurs or that some other outcome occurs? So I know it's a probability question. Now, they didn't do it in this particular question here, but often what they will do is they're going to ask you to make use of a probability tree, which you'll learn about in Chapter 6. Or they might ask you to make use of a table. They could call it a marginal probability table or a joint probability table. So we're either dealing with joint probabilities or marginal probabilities. Now, what I'm going to show you is that whether they ask for it or not, like they didn't ask for it here, whether they suggest you use this one or they suggest that you use a table of probabilities, I'm going to show you that you really need to do all of these things. You should use a tree, or you should actually, whether they ask for it or not, use both the tree and the table. Now here they just started asking me questions right away, but I'm going to work towards the tree and the table. The way I'm going to do that is I'm going to need to start off by reading through this here. So I'll do that now. And I'm going to pull out, you can see that there's some probabilities that are listed in here. I'll have to identify what these actually represent. That will allow me to put them on the tree. The tree is going to allow me to populate a table with all of the joint probabilities and marginal probabilities that I might need to go ahead and answer this question. So I'm going to get rid of the question itself, and I'll read through this, and then I'll get to work at making that tree. So I'm just going to clean this up a little bit, and then we'll get to work at deciphering or breaking down what's in this question in terms of the given information. Okay, so it says, a credit bureau studied its data and determined that 2.08% of credit cards became 90 plus days past due. Okay, so we've got a probability here. Now, what does this represent? Well, this is the probability that something, or there is a 2.08% chance that something occurs. What should I call that something? I can call it, well, why not? I'll just call it 90 plus. Usually I like to use a letter here, but I think that this makes it pretty obvious what's going on here. So this is the chance or the probability that it's due or it's overdue 90 plus days past due. And now you want to be careful that you don't just write 2.08 in here. This is a percentage, but we need a proportion. And the way that you get a probability or a proportion is you take your percentage and you divide that by 100. So 2.08 divided by 100 gives me 0.0208. So be careful about that. So this is 0.0208. So I've got my first probability identified here. The next thing it says is the data showed that 24.70% of credit cards that were 90 plus days past due had a subprime rate attached to the card. Here they describe what a subprime rate is. A subprime rate means that they may have difficulty maintaining the repayment schedule, and therefore the interest rate is typically higher on these cards. Okay, so we don't really care about what this is defined as. That doesn't affect us. We just need to know how to write this out. How does this 24.7%, how does it fit into our question? Now, once we've decided on a label, like we did in a previous probability here, like the probability of being 90 plus days past due, and we've given a value to that, we need to try and make sure that we stay consistent. So how does this relate? This says the data showed that 24.7% of credit cards that were 90 plus days past due had a subprime rate attached to the card. Now here you have to be very careful. I'll show you what it's going to look like when it's done. This is the probability of being subprime given we are 90 plus days past due. that is what's equals to 0.2470. The way I got this, once again, is I did the percent over 100. So that's 24.70 divided by 100. This gives me 0.2470. Okay, so that explains this part. But how did I decide on this? Well, this is what's called a conditional probability. And conditional probabilities are probably the most important part of Chapter 6. You really need to make sure that you understand what they are, what they mean, how they're set up like this, and also how to identify them when you've been given a paragraph, like a word problem here. So what it is that you're trying to identify when you set up one of these is is what is it that happens on this side and what is it that happens on this side. If you get them reversed, if you get them mixed up, you're going to get your question set up wrong, and you probably won't get very many marks. So I'm going to write it like this. I'm writing on this side what happens, and on this side I'm writing to who. Now this isn't a perfect system, but hopefully this will give you the idea as to how I think about one of these conditional probabilities. There's going to be another few ways that I'll talk about this, but this will just be how I start off. Basically, let me give you a really simple example about a conditional probability. The probability that somebody passing their test, given that they studied, is 90%. The probability of somebody passing their test, given that they did not study, so the C is a complement, so it means if S is studied, this is the complement, or we did not study. This might be 30%. Okay, so think about these examples here in terms of the probability of something happening. So this is the probability of passing, but so is this one. This is also the probability of passing. And I have different values. One of them is a very high value, one of them is a very low value. How can that be that the probability of passing changes around from a 90% down to a 30%? Well, it depends on who you're talking about. So if you studied, obviously that gives you a greater chance of passing. If you did not study, then you have a lower chance. So these are conditional probabilities. So this one here is the probability of subprime for people who are 90 plus days past due. Not everybody has this chance of getting a subprime rate. It's only if you are 90 plus days past due. So let's read that again and see if that was clear. It says the data showed that 24.7% of credit cards that were 90 plus days past due. So we know that we're looking at credit cards that fit into this category. So this is the group that we are talking about. 24.7% of those cards had a subprime rate attached to the card. So in other words, if we are talking about these cards, just like if we're talking about people who studied, then we can apply this probability. So the data showed that 24.7% of cards that are for sure 90 plus days past due maybe have a subprime rate attached to the card. So some of them do, some of them don't. 24% of them have that subprime rate. So the probability is whether or not you get subprime. But for sure, we're talking about the group that is 90+%. That's how I write them like this. It's the probability of subprime given that we're talking about these particular cards. This is the cards that it applies to. This is a tricky thing. You really need to go through a number of questions that are word problems like this to get a feel for how this works. Your chapter has some exercises. In fact, out of all of the chapters in the textbook, I would say that this chapter is the one that does the best job of setting you up properly for exam questions. There's a section on conditional probabilities. You really should be working through those. But let's continue on with what we've got here. We're going to have another conditional probability coming up. So let's keep reading. It says 96.44% of credit cards that were not 90 plus days past due had non-subprime rate attached to the card. Again, we get a description as to what that means, but who really cares? We don't need that. We just need to know how to identify this probability here. So first of all, let's move this one up here. So I'm just going to get this out of the way. S given 90 plus, that's what's equals to 0.2470. Okay, so now I can work on the other one here. And let's take this, let's work on it this way. How do I know that I'm even going to be dealing with a conditional probability? Well, the question that I ask myself is, does this chance apply to everybody, or to every card, or to every situation? 96.44% of credit cards that were not 90 days plus, or 90 plus days past due had a non-subprime rate attached to the card. So it's not 96% of all credit cards, it's only 96.44% of these credit cards. So that's just a limited group. So as long as we're talking about those that are not 90 plus days, then this probability applies. And what is the probability of? It's that they will get a non-subprime rate, so not subprime. So this is my final conditional probability. This, I would say, really, this list of probabilities that I've written down here, this is really where it's going to be decided whether or not you succeed in answering this question correctly or not. Identifying these probabilities properly is the hardest part of this chapter. Once you've gotten to this point, I'd say it's pretty straightforward after this. So again, the best way to do this is to not focus entirely on just trying to figure out what I said with this question. Open up some new questions. Have a look at how this approach applies in determining conditional probabilities. And remember, conditional probabilities are probabilities that do not apply to all situations. Like this one up here, this 90 plus, this is not a conditional probability. So it must apply everywhere. It says a credit bureau studied its data and determined that 2.08% of credit cards became 90 plus days past due. So this is a percentage of all of the credit cards. They didn't say of credit cards that act a certain way or do a certain thing. But here, when I have my first conditional, they do. They say the data showed that 24.7% of credit cards that were 90 plus days past due. Okay, so that's limiting ourselves to a group, the 90 plus days past due. Down here, it doesn't say 96.44% of credit cards. It says 96.44% of credit cards that fit a certain description. So that's how I know it's conditional. This was that they are not, that's what the C is all about. They're not 90 plus days past due. So they're not 90 plus days past due. Getting this down is of the utmost importance. But enough of that. We're now going to make use of this and make the probability tree. So let me get to work on that.